right, as we solve rational equations, another type of application problem that we will encounter involves motion, and this idea of distance equal to rate times time. So hopefully this is somewhat intuitive to you already. So if we're traveling down the freeway at a rate of 60 miles per hour for 1 hour, we will have gone 60 miles, right? So the d equals rt is really a linear formula, right? But if you solve d equals rt for r, for instance, and you divide both sides by t, you're going to get r equal to d over t, right? If you take d equal to rt and solve it for t, you have to divide both sides by r, and you end up with t equal to d over r. That one, the t equal d over r, is one that we're going to use quite a bit in solving some of these problems. So let's do an example. Eva walks 2 miles per hour slower than John. In the time it takes Eva to walk 5 miles, John walks 8 miles. Find the speed of each person. When we're talking about miles per hour and you're given some information about in the time it takes Eva to do something, it takes John can do something else. So that gives you some indication that we're going to be using that d equals rt model. All right. Now, one of the things that I recommend with this type of problem is to set up a little table. You don't have to, but I think it can be helpful. So we've got Eva and John, right? And we're given some information about the distance they walk, right? Rate, one in terms of the other, right? And also about time. Okay, so we know that Eva walks 5 miles in the same time it takes John to walk 8 miles. And Eva walks slower than John by 2 miles per hour. Okay, so we're supposed to find the speed of each person. So in terms of the rate, I could just let John be, the rate of John be J, and then John minus 2 would be Eva, right? Because she walks 2 miles slower than John. Now you could do it the other way. You could let Eva's rate be E, and then for John you could have E plus 2, right? um, Either way, however you want to work it. So, and you remember that d equals rt. If we divide both sides by r, we know that d over r is equal to t. Okay, so if I have some information about d and r, I can make a statement about t, right? So in Eva's case, t would be 5 over j minus 2. And in John's case, time would be 8 over j. Would also be good to state our variables here, right? So I'm letting j is John's speed, right? Get clear on that. And then the j minus 2 would be Eva's speed. Okay, so now what do we know? We've got this table going. Pay attention to time. So in the problem it says, in the time it takes Eva to walk 5 miles, John walks 8 miles. Okay, so the time that it takes them to do these things is the same. So the time for Eva was 5 over j minus 2. So that's equivalent to 8 over j, right? So if we're saying it takes the time it takes Eva to walk 5 miles is the same as the time it takes John to walk 8 miles. Okay, so now we have this rational equation that we can solve, right? And what's the LCD here? J times j minus 2, right? Okay, so on the left-hand side here, j minus 2 cancels out, and on the right-hand side, j cancels out. So on the left, I have 5j equal to 8 times j minus 2. Okay, so I'm going to distribute 8 through, so I have 8j minus 16. And I've got to solve for j, right? So I've got 5j minus 8j. I'm going to subtract 8j from both sides. Minus minus 16. Okay, so 5j minus 8j is negative 3j. And on the right-hand side, I'm going to have negative 16. Okay, so now divide both sides by negative 3. J is equal to 16 thirds. Okay, or 5.3 repeating, right? Miles per hour. Yes. And what do we know about Eva's time, which is j minus 2? So that gives us 5.3 repeating minus 2, which is 3.3 repeating. So we have the speeds, right, of each person. So let's put that into a complete sentence. John's walking speed is 5.3 miles per hour, and Eva walks 3.3-ish miles per hour, 3 1/3. All right. And the other thing I observe about these is that they're reasonable numbers, right? It's 3 1/3 mile per hour is a reasonable walking speed. John's walking speed seems a little fast to me, but maybe he's tall. All right.